Ever wondered how software testing is done? How do testers ensure that the software you use every day functions as intended? Well, let's embark on this fascinating journey to uncover the world of software testing. This process is crucial to ensuring that the software you use is reliable, performs efficiently, and most importantly, accomplishes what it's designed to do. Now, there are several ways to test software, each with its own unique approach and objectives. But today we're going to focus on two primary methods: white box testing and black box testing. White box testing, sometimes referred to as clear box or structural testing, is all about peering into the software's inner workings. On the other hand, black box testing, also known as functional or behavioral testing, concentrates on the software's external behavior and functionality. Intrigued? Let's dive deeper into these two essential software testing methods. Imagine being able to see inside a complex machine, understanding its every function. That's what white box testing offers for software. Peel back the layers of any software application, and you'll find a labyrinth of code, a complex interplay of logic and functions that makes everything tick. This is the realm of white box testing, also known as structural testing or clear box testing. It's a method that lets testers delve into the software's internal structure, scrutinize its logic, and examine its code. The primary objective of white box testing is to verify the correctness of individual components within the software. We're talking about functions, methods, and specific code paths. It's like taking a magnifying glass to the software's inner workings. This approach also helps validate the flow of control and data through the software's internal logic and decision points, ensuring that everything works as it should. But it's not just about making sure the gears turn smoothly. White box testing also plays detective, hunting for bugs, logic errors, and vulnerabilities in the code. It's all about identifying these issues, from boundary conditions to exception handling, before they can cause problems down the line. Now, how do we go about it? Well, there are several techniques at our disposal. The first is statement coverage, which ensures that each line of code in the software is executed at least once during testing. It's like reading a book from cover to cover, making sure no page is left unturned. Next, we have branch coverage. This technique verifies that all decision branches and conditional statements in the code are exercised. It's like exploring every possible path in a maze, ensuring no route is left uncharted. Finally, there's path coverage. This method tests every possible execution path through the software, including loops and nested conditions. It's like playing out every possible scenario in a game, leaving no stone unturned. In essence, white box testing is like an open book examination of the software's internal workings. It's a deep dive into the code, a detailed analysis that leaves no room for hidden faults or unseen errors. It's the key to delivering software that's as close to perfect as humanly possible. Now, picture testing a machine without knowing what's inside. Intriguing, isn't it? That's the essence of black box testing. Imagine you're a detective, and your case is a software application. You don't have any clues about the internal workings of the software, no access to its source code, but you have to ensure it's operating correctly. Sounds like a challenge, right? That's precisely what black box testing is all about. Black box testing, also known as behavioral or functional testing, is a software testing technique where the tester evaluates the application's behavior without peering into its intricate internal structure. The tester interacts with the software's user interface, inputs, and outputs, much like an end user would, to evaluate its functionality and performance. The objectives of black box testing are straightforward. We aim to evaluate the software's functionality, features, and user interactions from an end user perspective. We want to verify that the software meets the specified requirements, performs the expected operations, and produces correct outputs. And, very importantly, we strive to identify any discrepancies between the expected and actual behavior of the software. Now let's talk about some of the techniques used in black box testing. First up is equivalence partitioning. This technique divides the input domain into equivalence classes. From each class, representative test cases are selected. The idea here is that if a test case from a partition passes, the other test cases in that partition are also likely to pass. Next, we have boundary value analysis. This technique tests input values at or near the boundaries of equivalence classes. It's based on the observation that errors are most likely to occur at boundaries. Finally, there's state transition testing. This technique examines the transitions between different states or modes of the software. It's like observing how a chameleon changes its color in response to different environments. Black box testing is akin to a mystery, where the focus is purely on the output, irrespective of how the software produces it. So put on your detective hat and get ready to solve the puzzle of software behavior with black box testing. White box and black box testing may seem like polar opposites, but they are two sides of the same coin. In the world of software testing, white box and black box testing serve as two key methodologies that help ensure the quality and functionality of a software application. While they may seem distinct, both methods play a crucial role in the software testing process, each offering unique perspectives and insights. White box testing, also known as clear box or structural testing, is like an open book exam. It delves into the internal structure, logic, and code of the software application. Testers have full visibility into the software's inner workings, allowing them to validate the flow of control and data, verify the correctness of individual components, and identify errors within the code. Techniques such as statement, branch, and path coverage ensure that every line, decision point, and execution path is tested. On the other hand, black box testing, also known as functional or behavioral testing, is akin to a blind taste test. Testers don't need to know the inner workings of the software. Instead, they interact with the software's user interface, inputs and outputs, assessing its compliance with specified requirements and user expectations. The goal is to evaluate the software's functionality and user interactions from an end-user perspective. Techniques like equivalence partitioning, boundary value analysis, and state transition testing help uncover potential errors and discrepancies. So are they really that different? Well, yes and no. While their methods and focuses differ, both white box and black box testing aim for the same goal: to ensure the delivery of high-quality, reliable software. They provide different lenses through which to view the software, offering a more comprehensive understanding of its quality and behavior. White box testing allows for a deep technical understanding of the software, while black box testing provides a user-focused perspective, assessing how the software functions in the real world. By combining both approaches, organizations can achieve thorough test coverage and deliver software solutions that not only work as expected, but also meet user needs and expectations. Each testing method provides distinct insights, making them vital tools in the software testing process. You might be wondering, why not just pick one? Why do we need both white box and black box testing? Well, let's dive into that. Imagine software testing as exploring a new city. White box testing is like having a detailed map, allowing you to navigate the intricate alleyways, knowing where each road leads and what's behind each door. It's about understanding the city's infrastructure, its plumbing, electrical systems, and architectural blueprints. This method enables us to validate the internal workings of our software city, ensuring every line of code is executed, each decision branch is covered, and all paths are traversed. On the other hand, black box testing is like walking through the city without a map, experiencing it as a tourist. You're interested in the functionality of the city, the public transportation, the restaurants, the parks, the museums. You're not concerned with how the power grid is set up or the city's sewage system. Instead, you're observing whether the buses run on time, if the food tastes good, and whether the parks are clean and safe. This testing method lets us evaluate the software from an end-user perspective, verifying that it meets specified requirements and produces the expected outputs. So why do we need both? Because each method offers a unique perspective and insights into the quality and behavior of our software city. White box testing lets us verify the correctness of the individual components and validate the flow of control and data through the software's internal structure. It's crucial for identifying errors, bugs, and vulnerabilities within the code itself. Black box testing, however, allows us to evaluate the software's functionality and features from an end-user perspective, identifying discrepancies between expected and actual behavior. By combining both approaches, we gain a comprehensive understanding of our software. We ensure that not only is the code internally sound, but also delivers the desired external behavior and functionality. These methods are not rivals, but partners in the quest for high-quality software. They complement each other, providing thorough test coverage and a holistic view of the software performance. By integrating both methods, we can ensure the delivery of high-quality software that meets user needs and exceeds expectations. In the world of software testing, there's no one-size-fits-all approach. we've delved into the intricacies of both white box and black box testing. White box testing, with its focus on the internal structure, logic, and code of the software, allows us to verify the correctness of its implementation. Black box testing, on the other hand, validates the software's external behavior and functionality, truly putting it to the test from an end-user perspective. These two approaches are not mutually exclusive. Rather, they provide unique perspectives and insights that, when combined, offer a comprehensive view of a software's quality and behavior. By incorporating both white box and black box testing in your strategy, you can achieve thorough test coverage and ensure the delivery of high-quality software solutions. Remember, the goal is always to deliver software that works seamlessly, providing a superior user experience. And that's where white box and black box testing come into play.